Our new entry is on the quadratic formula. So we've learned how to solve by graphing the quadratic equation. We've learned how to solve by taking the square root. We've learned how to solve by factoring. But there are some instances where we need a different strategy to solve a quadratic equation. For example, and don't write this down, but what if you were given the quadratic equation 3/4 x squared plus 2.67 x minus 0.013 equals 0. Now how on earth are you going to factor that? Or even graph it, right? Because you've got fractions, we've got decimals, we've got a lot of stuff we'd have to work with. So mathematicians tried to find a simpler method. And what they found was, through a what's called completing the square, they came up with a general pattern and a quadratic formula that works to solve all quadratic equations, as long as they're set equal to 0. And that pattern is this. Now, it looks a little complicated at first. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so when I'm given a quadratic equation, I've got an a, b, and a c. You're used to seeing what a is, what b is, what c is, because you've had to find the axis of symmetry before. So this is just another formula. You can kind of see the axis of symmetry right away too. You notice it's negative b over 2a. And we'll kind of circle back to that in a second. But we're going to get practice with solving an equation using the quadratic formula. Our first example is going to be to solve x squared minus 2x minus 8 equals 0. Now, if I were given this equation right off the bat, it looks like I can factor it. So let's do a little review and solve this one by factoring. I don't have to slide anything over. I could right away just use my x puzzle. Numbers that multiply to negative 8 but add up to negative 2 are negative 4 and positive 2. Putting those two solutions into my factored form is x minus 4 times x plus 2 equals 0. And then I would break it apart and I would use the zero product property to say that either x minus 4 equals 0 or x plus 2 equals 0, which means x must be 4 or negative 2. So that's how we solve by factoring. Now, it was pretty short solving by factoring, right? It only took a couple of lines. We're going to get used to using the quadratic formula to solve these equations. So we're going to start with a simpler one, so it's easier to substitute in and get used to that. So here's an example of, again, factoring it. And as I've said previously, you are learning so many different methods to solve quadratic equations. No matter what method you use, as long as you're not estimating and you've done all the math correctly, you should get the same answer. So if I graph this, if I factor it, or if I use a formula, I should always get a solution of 4 and negative 2. So let's use the formula and see if that's what happens. What I like to do when starting off a problem, especially using the quadratic formula, is I'm going to label my a, my b, and my c. And I'm going to do that right on the side here. So a is equal to, well, there's no number here, so a is equal to 1. So it's kind of that imaginary 1 that's in front of the x squared. B is equal to negative 2. And C is equal to negative 8. So remember, we have to take the signs when we do this. And using the quadratic formula, we are just substituting in now. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so divided by 2a. And now we're just going to substitute in. So I've got negative, and I'm going to use color here to make it easier for the example, b plus or minus, we have to account for both. So as we start to move through this example, you kind of understand what a plus or minus symbol means. Just to give you kind of a hint of where it's going, you'll remember back when I said when solving by graphing or solving by factoring that if the exponent is 2, then there's probably going to be 2 solutions. This plus or minus allows us to manipulate the formula, but still come out with 2 solutions at the end, instead of having to do the formula twice. One where we're adding this value, and then another time when we're subtracting this value. So this is what the plus or minus symbol means. So again, negative b plus or minus, now I have the square root of b squared, so that's negative 2 squared minus 4 times a, which is 1, and then times c, which is negative 8. Close the parentheses, and that's all over 2 times a, which is 1. And I kind of forgot the most important part. It's x equals. Right? And the process we go through is just doing the math out, really. So I'm going to keep going through my quadratic formula, and you can notice that this might start taking up quite a bit of space, but we're going to power through it. Negative 2 is positive 2. Again, plus or minus. And then I have the square root. Negative 2 times negative 2 is positive 4. And I'm subtracting. 4 times 1 is 4. Times negative 8 is negative 32, so I'm subtracting negative 32, and that's all over 2 times 1, which is 2. And I keep going. As you start to familiarize yourself with the quadratic formula, you'll be able to skip steps. 2 plus or minus the square root of 4 minus negative 32 is 4 plus 32, which is 36, and that's all over 2. And that equals 2 plus or minus the square root of 36 is 6 over 2. So what does this mean, right? I've simplified this down all the way to this plus or minus symbol, and now I have to work with that. Well, like I said before, the reason that we can use this symbol, or we do use this symbol, is so we don't have to do this process multiple times. So once we're here, we have to account for the fact that there are 2 solutions. So x can either be 2 plus 6 divided by 2, or 2 minus 6 divided by 2. And so I solve those each separately. X equals 2 plus 6 is 8, divided by 2 is 4, or x equals 2 minus 6 is negative 4, divided by 2 is negative 2. So x can be negative 2 or 4. And then in roster form, x can be negative 2 or 4. And that's how you use the quadratic formula. And if you take a look back at what we had previously, we still got x equals 4 and negative 2. But let's take a look at side by side here. The right side we solved by factoring, and the left side we solved by using the quadratic formula. I would have solved by factoring, certainly if I was given this case, given this quadratic equation, and not told how to solve it, because look how short it was. Right? And then the quadratic formula took all of this. So if you can factor it easily, if you can graph it easily, or if you can find the square root of it to solve for x, those are probably going to be simpler solutions, but it all depends on the quadratic equation that you have. Our next example, if you turn the page, is to solve 3x squared minus 41x equals negative 110. So I want to be able to solve this by factoring, by graphing, quadratic formula. In this case, we are going to use a quadratic formula, but in every situation I have to get this equal to 0. So my first step is going to be to make it look like it's in standard form and then equal to 0. So I'm going to add 110 to both sides, and I'm left with, and I'll start writing it over here, 3x squared minus 41x. And I can't add the 110 to anything, so it stays as plus 110 equals 0. And now I can use the quadratic formula because I've got an a, I've got a b, and I have a c. If I were to solve by factoring, I'd have to slide over, right? So this would become 3 times 110, 330, and then have to come up with two numbers that multiply to get 330 and add up to 41, and it would just be kind of difficult. I might be able to find it, I might not be. It depends how good I am with my multiplication facts. So let's use a quadratic formula to solve this one. I've labeled a, b, and c, so now I'm just going to put them into the quadratic formula. So I've labeled my a, b, and c and wrote them on the left side, and when I put them into the quadratic formula, I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I keep going with that. So negative 41 is a positive 41. Negative 41 squared is 1,681. 4 times 3 times 110 is 1,320. And 2 times 3 is 6. So I'm just going through the process for each step. Doing that subtraction inside the radical, I get 41 plus or minus the square root of 361, again over 6. The square root of 361 is 19, so I've got 41 plus or minus 19 over 6. And finally, I have to account that it's a plus and a minus, so that means that x can either be 41 plus 19 divided by 6, or 41 minus 19 divided by 6. And I keep doing the math out for that. 41 plus 19 is 60 over 6. 41 minus 19 is 22 over 6. And so I get as my solutions, x is 10 and x is 11/3. So in roster form, that would be 11/3 and 10. So as a full page, you can see that I've used the quadratic formula and shown all my steps for this one. And I got a solution of 10 and 11/3. Now that you've finished example 2, I want you to do these two problems on the left side. Solve x squared plus 2x minus 15 using the quadratic formula. And solve 2x squared minus 3x equals 4 using the quadratic formula, and round to the nearest tenth if necessary. Kind of a hint that you will have to round in this one. When you're finished with these two, have your teacher check your answer and then move on to example 3. Our new example is to solve x squared minus 6x plus 11 equals 0. So again, like before, I'm going to label A, B, and C. So A is 1, B is -6, and C is 11. And when I substitute those values in, I've got x equals -6 plus or minus the square root of -6 squared minus 4 times 1 times 11, and then all over 2 times 1. And now let's go through the process of trying to solve this one. So x equals -6 is a +6 plus or minus the square root of -6 squared is 36. I'm subtracting 4 times 1 times 11 is 44. All over 2 times 1 is 2. And I've got x equals 6 plus or minus. Now 36 minus 44. So it's a square root of -8. All over 2. And that should look funny to you, because we can't take the square root of a negative number. So if you think about it, 2 times 2 is 4, which makes sense because the square root of 4 is 2. Also, -2 times -2 is 4. So the square root of 4 can also be -2. But whenever you're multiplying a number by itself, which is how you find out what the square root of a number is, you're not going to change the sign of that number. So it's either going to be a positive times a positive, which is a positive number, or a negative times a negative, which is a positive number. So we can't take the square root of a negative number. And I want you to write that down in your book because it's really important. We've seen that situation occur when we graph, but here you can't have the square root of a negative number So we can't have the square root of a negative number and that means there is no solution. And if you were to use set notation, that would look like the empty set. No solution. So in example 3, we got a solution of, well, no solution, because we couldn't take the square root of a negative number. So this part of the quadratic formula right here tells us a lot about the kind of solutions that we're going to get. And let's take a look back at the generic quadratic formula. X equals negative b plus or minus the square root of, and then b squared minus 4 times a times c. So just this value here, the value that's inside the square root, if that's greater than 0, like it was here, right, it was 36, then we're going to have two solutions. And the reason we're going to have two solutions is because we have to account for the fact that we are adding a number and then subtracting a number. So that gives us two separate answers. Now, when that number inside the square root is less than 0, like we saw in example 3, right? There can't be any solutions because there is no square root of a negative number. And flipping back, if that number under the square root were to equal 0, then this whole thing would go away. And when we would be adding and subtracting, right, plus or minus, nothing. So there would only be one solution, and that solution would be the axis of symmetry, which is kind of a cool balance, how everything synchronizes in math. So this value here, this formula b squared minus 4ac, we call that the discriminant. So the value b squared minus 4ac is used to tell the amount of solutions to a quadratic equation. Use the following table, okay, which is right here, for the solution. So I want you to put this into your book as the very last key idea, the discriminant. If that value is greater than 0, then there are two solutions. If it is equal to 0, there's one solution, and if it is less than 0, there are no solutions. So the title of this page, instead of being the quadratic formula, we're going to title it the discriminant. On the left-hand side, you're going to solve these three problems. You're going to find the value of the discriminant and the number of solutions to the equation. So for each one, you're stating what the discriminant is as a single number, right? The b squared minus 4ac. And then how many solutions does that equation have? You don't have to give the actual solutions, you just have to state whether there's going to be 0 solutions or no solutions, 1 solution or 2 solutions. And that's it for this entry. And the next step is the practice, and then moving on to the test.